I will continue insisting on you showing me the method and explanations during the test on the problems. One of the reasons is that I want you to learn the method. It's not about teaching you how to do these particular problems. Velocity problem, area problem, work problem. We can cover only finitely many of them, right? And then there is no guarantee that next time you see a problem that requires integration, you would recognize that integration is useful. So instead of going by examples and learning those examples, I would like you to learn the method. And the method is something I will repeat in each of the problems. And the method is cutting things into pieces, recognizing each piece can be represented in a special form, approximated by a special shape or formula, and that special formula must be a certain product, and then the total thing is the limit of sums, and this is what I insist on you explaining. All right? Not saying that, oh, I recognize, yes, in this problem I do the integral. No, you do those step-by-step explanations. And basically what I hope for is that by the end of the semester you will be able to solve any problem from, say, engineering that requires integration without knowing the formula. All right? So basically, knowing the method, you should be able at the end to not only outline the solution of a known problem, but actually to say exactly and specifically what kind of information you need to solve that problem. If someone asks you, well, let me just give you an example to keep in mind. Take a spring, and there is a standard problem on integration from in any textbook about stretching the spring. Now, instead of taking that standard problem, I'll ask you this. What if the spring has length L and the spring is heavy, and now I take this spring at one end and let it hang freely? Well, of course, spring will be longer, right? It will stretch. Now, the problem is to find the length of this stretched spring. And that problem is not one of those standard textbook problems. And there is no formula in the textbook given. And I seriously doubt you can figure out the formula just by thinking about it, right? But what I'm saying is that if you follow this procedure of setting up the integral, you should be able to come up with a specific list of things you need to complete the problem. Not only you will have a way to solve the problem, but you will have questions for engineers. In order for me to give you the answer, you have to give me such and such parameters of the spring. And this is exactly and precisely what I need. Right? So don't give me a lot of information, what kind of material, what kind of this, what kind of that, right? We will know exactly what's needed. And in general, the problems are more like that in reality. You are not given everything you need, and you are usually given much more than you need. And then you have to figure out what's important, what's not important, what's needed, and what's not. So I'll keep going through simple examples. And those examples will become more and more complicated in time. And in a month, we will face this kind of problems. And in 2 months, we will face more complicated problems. But we need some machinery to build up. And I need you to learn those methods. And also for other kind of problems, I need you to learn methods using vectors, dot product, area formula, well, area product that it will be called vector product in the future. So I need you to learn those methods. Not solve the problem, right? This given problem. I know those problems have other solutions, but I will need you to stay within the methods covered in class.